Hello AP Statistics students. We're now in Chapter 8, and Chapter 8 covers two types of distributions, binomial and geometric. And with this particular video, we're going to cover binomial distributions and what makes something a binomial distribution, and actually what differentiates it from a geometric. And we'll catch up on that later. The first thing we want to talk about is the word bi, and you know from other classes that the word bi means two, bicycle, so that prefix means two. In this particular case, the two somethings we're talking about are success and failure. Those are the two options, the only two options. Sometimes in this particular chapter, what we consider as success might be a little morbid. I mean, one of the problems we're talking about are the teen deaths while driving. While we're looking at teen deaths, we're going to consider that as success, because if we see one, then that's what we're looking for statistically speaking, although it is kind of morbid. A binomial setting would be like the example that we had with the couple who wanted to know the probability of having a girl. They were going to keep having the girls until keep having children until they had the girls. And we looked at what was the probability of having two girls or all girls. Remember, they stopped, I think, at 4 children. So to have a binomial setting, the following criteria must be met. Now, there are 4 different criteria that have to be met, and they're very similar to the geometric distributions that we'll talk about at the end of the chapter, with one exception. Now, the first one we're looking at is the outcomes fall into one of 2 categories, success or failure. Okay, so that has to happen. There are no other options. The second one we're looking at is a fixed number of observations in. So every one of the problems that are binomial will tell you, like in the examples that we look at in the book, they'll say that there are 5 children that they're looking at the types of blood, their blood types. There's another one where they deal 10 cards from a deck. Another one engineer looks at 10 switches. So another one looks at 350 engines. So they'll always tell you how many that they are looking at in that particular set. And that's a big deal, because that's going to differentiate binomial from geometric later on. So you'll see. So number 2, a fixed number of observations in. Always look for that in your problem. Number 3, the observations are independent. So that means that if you look at one, then it's not going to affect the probability of the next one. Okay, so we know what independent means. And then the fourth one is the probability of success, we'll call it P in this particular case, is the same for all the observations. So if someone is shooting a free throw in a basketball, we'll consider that one free throw has the same probability of success as the next free throw, or the one previous to it. Now, the formula for calculating probabilities is rather nasty. Woo, okay, let's hear the boos. All right. But fortunately for us, we get to use the calculator for most of the work. All right, we still have to know what it means, and we still have to know how to put it in a calculator, but we don't have to. We know College Board no longer requires us to mess with the nasty formulas. A binomial distribution is denoted with a capital B and in parentheses N, P. And where N is the number of observations that you'll find in the problem, and the P is the probability of success of any one of the observations. And generally speaking, the P is given also. Not always, but it's generally given to you. Now, notice this and how this is denoted compared to a normal distribution. Now, remember, the normal distribution had N, and then in parentheses we had mu and standard deviation. So if you see this or normal distribution, you kind of know how to put one together. Okay, make sure that you read the examples 8.1 through 8.8 very carefully in our book. They're all good examples. Look for those things that we just talked about, those 4 different criteria. Look for N. Look to see if they're independent. Look to see if the probability of one is the same as the other. And look to see if we're only looking at success or failures. You'll see. These are really good examples, and they'll really help you out. Okay, now, do you remember discrete random variables from Chapter 6? We talked about discrete and continuous. Now, discrete were the ones that we can count on our hands and toes, right? So, binomial distributions use only discrete random variables. Now, we'll be using PDF a lot. Remember, we never used that when we had the normal distributions. No PDF. We always use CDF. Now, it stands for probability distribution function. And read the formal definition on page 443. But it really means the probability of exactly one variable, X, the event happening. Almost always, not always, but almost always, that you'll see the word exactly in there. So, for instance, the probability of the couple they would have exactly 3 girls. And notice how the symbolism is on this particular presentation. You have the probability, parentheses, X equals 3. So the event in this particular case was having 3 girls. Now this chapter is going to test you on paying attention to conditions like no more than, at most, more than, at least, and many other words. So you've got to be very, very careful in the reading. Whenever you're highlighting the problems, you're underlining the problems, make sure that you look for these words. Okay, now if I told you, if I said, what was the probability, if I asked, what was the probability of the couple having no more than 2 girls, then I would be looking at the following equation. Now remember, no more than 2 girls. Does that include 2 girls? Yeah, that's acceptable. So when we write it up, it's the probability of x is less than or equal to 2. And what that can mean, we can have 2, or 1, or 0. And remember from chapter 6, when we say or, what do? You add. So we have the probability of x equals 0, plus the probability of x equals 1, plus the probability of x equals 2. You add those together. This follows the same probability rules that we saw in chapter 6. Now, let's put the calculations to work. One of the better examples here that I like was example 8.5, and let's walk through it together. This is directly from your book. Okay, a quality control engineer selects a simple random sample, SRS, of 10 switches from a large shipment for detailed inspection. Unknown to the engineer, poor guy, 10% of the switches in the shipment failed to meet the specifications. What is the probability that no more than 1 of the 10 switches fail inspection? So what are we looking at here? No more than 1. Okay, I'm thinking about this. No more than 1, that's 1 or 0. Right? 2 doesn't count. If you think about 2, that doesn't work here. So when you write it up as a probability, what does it look like in binomial notation first? Well, it's going to be the binomial, alright, B, parentheses 10, comma, 0.1. Now that 10 represents the 10 switches, the sample size, and the 0.1 is the probability of success of each one, which in this case, that the switch fails. Second, how's the probability written? Now remember, it's no more than 1. So that's going to be x is less than or equal to 1, and it's 0 or 1, and when we say or, once again, we add the probabilities. Now let's go and find out how to do this on the calculator. So you're going to go to second vars, which is your distributions, same place that you've always done your normal CDF, but then you're going to, it's probably easier for you to scroll up than down on some of the calculators, the TI-83s or TI-84s, but you're going to go up to O, which is Binom PDF. Be careful, make sure it's PDF and not CDF, and hit enter. First, on the first one, you're going to put Binom PDF, put 10, comma, 0.1, comma, 0. The 10 is your sample size, the 0.1 is your probability, and 0 is that particular event that you're looking for, exactly 0. Now do that for both 0 and 1, add them together, and that's your answer. Okay? Now, suppose that you had a problem that wanted to know if there were no more than 100 of something was a success. Oh my goodness, 100, so that means no more than 100, so that means that it could be 100 or 99 or 98 or 97, and all of those all the way down to 0. Oh man, that's too many to add up. This is crazy. Alright, we will be here all day for a problem like this, but don't panic. This is when we go and we use, oh, this is where you say heck no. Okay. This is where we use the CDF part, like we had in normal distributions. So you say, go to the calculator, and we're going to take, and you're going to go to Binom CDF. And now this is where you have to pay attention. Are we going to the left or to the right? Remember, if you're going to go to the right, if it says at least or more than or greater than or all of those, you have to be careful, because just as we did in normal CDF, you're going to have to subtract it from 1. Okay? Because you know all the probabilities add up to 1. Okay, I hope this helps. Go ahead and get started with the problems in the book. Tomorrow in class, remember, this is all you have to do with this lesson tonight. Take notes, go through this again, and if there are any questions tomorrow, please ask. Thank you.